So we're going to begin by reading the directions, and what's helpful here is this reiterates the information that we just covered as we learned how to balance equations. So the information is repeated, that's a good thing. So it reminds us of why we balance equations. And here it says, atoms are not created nor destroyed during a chemical reaction. Again, that matter does not poof, disappear, or poof, appear out of nowhere. And scientists know that there must be the same number of atoms on each side of a chemical equation. That reflects the law of conservation of mass. To balance the chemical equation, you must add coefficients in the front of the chemical formulas. In front of the chemical formulas, not in between them. You cannot add or change subscripts. We don't pick on the little guys. You do not add or change subscripts. I would underline or highlight or circle, kind of yell at yourself like, hey, remember this. This is important. These are the things I cannot do. I can add a coefficient. I can't touch a subscript. And then it reminds us of our steps to balance an equation. And so we're going to start to work through this first one together. And it's kind of set up in a chart for you already, so you don't need to set up a chart. But what I like to do when it's set up in this format, as a lot of the practice that I give you will be, is I like to draw a line through my yield sign so that it separates the reactant side from the product side. And for now, I'd like you to practice doing this just as I am. So do me a favor and draw a line through the center of your equation showing the reactant side and the product side. So we have our equation. What's the next step? What's really the first thing we need to start doing? Look back to your notes or look at the steps there. What's the next thing we need to start doing, Michael? Right, and we've got our chemical formulas written right here. Now what? Holly?
Determine the number of atoms on each element.
We're going to determine the number of atoms. I call that atom inventory. We're going to take inventory of our atoms, aka counting atoms. We start by counting. So let's do that. For our reactant side, how many magnesium atoms do I have on my reactant side? I have one. Very good. On my reactant side of the equation, how many oxygen do I have, Lily? W. I have 2. Good start. Now I'm going to hop over to my product side. The law of conservation of mass states that the elements that I start with, I must end with. I see that Mg is over here, Mg is over there, O is over here, O is over there. I'm trying to make sure that I have the correct number of atoms on each side. You'll notice that I don't have a carbon over here or a lithium over here. Okay? Because I didn't start with carbon or lithium. Matter doesn't appear or disappear. So on my product side, how many magnesium do I have? Jacob? 1. How many oxygen do I have, Molly? 1. Is this a balanced equation? No, it is not. My magnesium looked pretty good across the board. Remember, you're just looking for each individual element to match up. I'm not looking for my magnesium to match my oxygen. I'm looking for my magnesium on the reactant side to match my magnesium on the product side. Those look good. My oxygen, however, do not look so good. They do not match up. So where am I? I can't have oxygen disappear. So there's no way I can decrease the oxygen. But I can add molecules by adding coefficients to increase the oxygen on my product side, which is what I want to do. And how can I do that, Alex?
You add the coefficient 2.
On which side?
For the product.
Correct. He says I'm going to need to add a coefficient of 2 to the product side. So when we do that, we'll then want to make sure that we recount our atoms. And again, we're not going to erase, we're just going to mark through our original answers. This coefficient applies to the whole formula, so we're going to be recounting both magnesium and oxygen on the product side. So when we do that, we know that the coefficient distributes to all parts of the formula, changing our magnesium to 2 and our oxygen to 2. Well, we did a really nice job of balancing out our oxygen, but in the process, we threw off our magnesium. That's okay, that happens. So now, is there any way we can then improve this equation to balance this equation? Were you ever told you can only add one coefficient and then you're done? After that, it's just you can't balance that equation. No. Sophie, what do I need to do? I can add a coefficient of 2 to magnesium. Where?
On the reactant side.
Very good. On the reactants side. So let's do that. And recount. Cross out, don't erase, please. Now again, why does the coefficient of 2 not apply to my oxygen? Why does the coefficient of 2 not apply to my oxygen? Matthew?
Because they are separated by the plus sign.
They're separated by the plus side, which means they're separate formulas. This 2 will not be distributed to this formula, only this one. So now, do my magnesium atoms match? I have 2 atoms that reacted to form 2 atoms. Do my oxygen match? They do. I have 2 oxygen that react to form 2 oxygen. You should always have the same number of atoms for each element on each side. That reflects the law of conservation of mass. So this is a balanced equation. 2Mg plus O2 yields 2 MgO, magnesium oxide. Okay, that's a pretty easy one. They do get more challenging, but we're going to do another together. We start, I like to draw a line just to separate. It helps separate the sides. I'll even label. Let's start by counting our atoms. How many calcium do I have? Isaac, on my reactant side. I have 1. How many oxygen, Preston?
2.
I have 2, very good. Hopping over to, we see we have the same elements, we're just checking on the numbers of those atoms. Amanda, how many calcium?
1.
Good. And how many oxygen, who am I not called on? Simone.
1.
Good. Calcium looks pretty good, oxygen not so much, kind of a similar issue to the last example. So I find that my oxygen are slightly needy over here. I can't remove any, but I can add coefficients to change my situation on my product side. Kate, what should I do?
Coefficient of 2 to the product side.
Very good. I'm going to add a coefficient of 2 to the product side and then recount my atoms as it distributes to the entire formula. So just like the last example, we've balanced out our oxygen, thrown off our calcium, and just like the last example, which is almost identical with different elements, isn't it? Ellie, what am I going to do on my reactant side now to help balance my calcium?
We're going to add a 2 to the CA
Okay, and what do we call that to?
coefficient.
Very good, my dear. Add a coefficient of 2 in front of the calcium. Recount. My calciums now match. My oxygen now match. Very good. I'm going to allow you to practice just the remaining 3 on this page. I do not want you to go further than that. You are practicing just the remaining 3 until the end of class. I am insisting that you not include this to your homework. I really, really, really want to work on it together more before I let you take off on your own at home, all right? So this is not for homework. We're just working to complete the last 3 on this page.